we are moving on to the next topic, which is mechanical translational systems. So what is a mechanical translational system is, here we are going to consider a component on which the force is going to be given. So when a block of a box or a block of iron box or a wooden box is taken, and I am going to give a force on one side, and I am expecting the output force on the other side. So we are going to say what are the components or what are the basic elements that's going to affect that input force. So first one is the mass of the object, and second one is the spring or the elasticity of the object. Third one is the dampness or the dashpot of the component. So when you are going to push an object, if the object is so heavy, your input force will be absorbed by the mass itself. So we will consider the object is going to be an iron box of 5 feet high. So that's going to be equivalent to your height. So when you are going to push the box, since the box weight is so high, you cannot push it because the entire force given is absorbed by the mass itself. Second thing, you consider the object to be an elastic, something like a rubber or a plastic of 5 feet high. You are going to push the object is going to bend. It will not move. It's going to bend a bit, so the force which you are going to give is absorbed by the elasticity of the object. The third one is dampness. The dampness is going to be the friction between the object and the floor below. So it will have some friction, or if it is going to be a slippery surface, the friction will be less. So these kind of things will be going to vary the translational systems. So we are going to consider each and everything. So here the weight of the is represented as elemental mass, and the elastic is called spring, and the friction is considered to be dashpot. So here the list of symbols that is going to be followed in this mechanical translational problems are: x is displacement, dx by dt is velocity, d square x by dt square is acceleration, and the F is the applied force, the force which is going to be given by us, and Fm is the opposing force offered by the mass of the body. Fk is the opposing force offered by the elasticity of the body. Fb is the opposing force offered by the friction of the body. So M determines the mass, K determines the stiffness of the spring, and B determines the friction. All these components works under the Newton's second law. Here it states that the sum of applied forces is equal to sum of the opposing forces on the body. We will see it clearly when we are going to see the problem. So the force balance equations. Yes, this is the idealized. We are going to consider an ideal element, and we are going to derive a force balance equation. So as I said earlier, we are going to give a force on an object, and the object is going to react based on the mass or elasticity or the dampness, and it's going to give an output force. Here I am considering a mass, ideal mass element, which doesn't have a friction or elasticity, or else a negligible friction and elasticity. So a force is given on the object, and the opposing force given by the object will be mainly due to the mass of the object. So I am considering an ideal element like this. So when I am going to give a force F, and it's going to give an opposing force that is basically based on the mass of the object, so it is Fm, opposing force due to the mass. So Fm is directly proportional to d square x by dt square. To remove the proportionality constant, we are introducing the constant m. M is the mass of the object. So is Fm equal to m into d square x by dt square. This is ideal condition. So similarly, we will go to the second ideal condition. Here I am considering an ideal friction element where it has negligible mass and elasticity. So there is a high friction between the object and the base below. So whenever the force is given on the object, it is completely opposed by the friction of the object itself, object and the floor. So that opposing force due to the friction Fb is directly proportional to dx by dt. That is, the proportionality sign is removed by introducing a constant b. This b is the friction constant. So Fb is equal to b into dx by dt. Similarly, when you are going to consider the frictional element, and this displacement is based on two different types of displacements. When you see the problem, I will explain it clearly. So here they are given two displacement x1 and x2, and the friction element is placed between two displacements. So the answer Fb is proportional to d by dt of x1 minus x2. So since it has only one displacement, it has been mentioned in the previous formula as Fb equal to b into dx by dt. In the third one we have a two displacement quantity, so it is x1 minus x2. So we'll move on to the third ideal condition. It is ideally elastic. It doesn't have mass and friction, that is negligible mass and negligible friction. So the force applied is completely opposed by the opposing force due to elasticity, which is termed as Fk. Fk is proportional to x, that is Fk equal to k into x. Here also, if you have two different displacements such as x1 and x2, we will write as Fk is proportional to x1 minus x2, that is Fk is equal to k into x1 minus x2. So with this we have completed the mechanical translational systems. So if you like this mechanical translation problem video, kindly share it with your friends and subscribe the channel and click the bell icon to get constant updates. Thank you.